Assalamu alaikum. On behalf of Ahsan Academy, let me welcome you to a presentation on peritoneum, and this is the first part of a series of presentation. In this part, I'll try to discuss the embryological background of formation of the abdominal cavity and how the peritoneum is embryologically formed, and ultimately we will proceed towards defining the peritoneum and its distribution, and at each stage as usual we'll do some clinical correlation. In the third week of development, we'll get the germ disc like this one. You can see germ disc is leaf-like structure at that time, and the third layer is starts appearing during the third week and in between the two layers. So it looks like this one. This is the germ disc, and this is amniotic cavity side, and this is yolk sac cavity side. So this third layer continues to form. This is mesoderm, and on the amniotic side this is ectoderm, and this one is the endoderm. So this third layer is formed by gastrulation, and the process continues. The disc starts folding, so this folding is towards the yolk sac cavity, and the folding continues side by side as well as proximal and distal part also. So this process continues, and the major part of the yolk sac is separated, and this one part of the yolk sac become trapped within the developing human body. So this is the back, and this is the front side. The process of folding continues. This is side to side folding. So the mesoderm shows a splitting into two layers, and in between that the cavity appears. So in the second part you can see the cavity is trapped, and part of the yolk sac is trapped within the body, and this is connected still with the yolk sac by a stalk, and you see the process is continued. So this one is the germ disc, looking like this one, a bit human like figure appear. You can see this is the ectoderm. So this one is the ectoderm covering the outer part, and inside this is the yolk sac lining is the endoderm, and this has ultimately forming the epithelium of the gut tube. This is the cavity you can see surroundings this gut tube. So the yolk sac is connected to the gut through a tubular structure. This is passes through the body, enter into the body through this umbilicus. So we can see at the level of the umbilicus the figure like this one, but if you go below you'll not get this stuck. This is for below the level of this one. So this is the gut tube you can see, and transverse section you can see this yolk sac is connected with the gut tube, and below this level it looks like this one cavity, and at this level you can see this is the connection with through this umbilicus. So this is the embryo. It's a folding, starting of the folding. This is longitudinal section. Yolk sac is connected with the developing gut tube. This is the gut tube area, and this one is the wall. And afterwards, if you get a section above the level of this one, this is looking like this one. Gut tube is at the middle, connected posteriorly by a fold, connected anteriorly, this is the ventral, by another fold. You can see this is the connection with the yolk sac, and this one is the gut tube, and the mesoderm is showing one cavity inside. So this has become body cavity. You continue we'll find like this one. This is the embryo proper, and gut tube is there connected to the postural by one fold and ventrally by one fold, and this is the cavity. So the cavity is lined by a sheet, a layer of cells on connective tissue. This is the peritoneum. So the whole peritoneum is lined by this epithelium and connective tissue, and this is the cavity trapped inside. So above the level of this connection, we will get the dorsal mesentery as a dorsal fold as well as ventral fold. So fold of peritoneums to keep the guard in position and a suspended position. This part is going to develop from the stomach. So if we look at, this is the level below the connection, and this is the section above the connection. So this lining part is the peritoneum, and this is the cavity. So it has the visceral layer. The peritoneum covers the developing gut. So this is the visceral layer that is tightly adherent to the developing organ, and the parietal layer means it is covering the wall. This is continuous by a fold. So this is the peritoneal fold. So peritoneum is now having three components. Covering the wall is the parietal layer, covering the viscera is the visceral layer, and in between this is lining the folds. It's connecting the viscera to the wall. This is the cavity. So this is now known as peritoneal cavity. This one above the level of connection of the yolk sac, this is having two cavities. One is, this is embryo back, so this is left cavity, and this one is the right cavity. So below the connection there's only one cavity. So now this cavity is continuous with left one as well as the right one. So both cavity is continuous below the level of connection of the yolk sac with this larger cavity. So it is having two folds and two cavities. It is above the level of the umbilicus, and below the level of umbilicus there is only dorsal connection, and there is dorsal fold and only one cavity. This is the developing embryo, and yolk sac is connected through the umbilicus with the guard, and you can see this is the, at this level we get section. This is looking like this. This is actually the developing liver bud. So below this level it's looking like this one. So two folds are there above, and this is the ventral fold, and up to the opening of the bile duct this ventral fold is present, and this is formed by the septum transversum tissue. So this is derivatives of the septum transversum, and below this level you see this is the embryo, and at this section means above the level the ventral folds showing development of the liver. So the ventral fold is now divided into two parts by the developing liver, and below this section you will get the ventral absence of the ventral fold and only dorsal fold is there. Here the dorsal fold shows the developing spleen. So now ventral fold is divided into two parts. This is one part, this one is the second part. Dorsal fold is also having two component parts. This one is the enlarged view of the previous slide. So let us see, this is the developing stomach. It is part of the guard tube, and this is connected to the anterior wall by the ventral mesentery, in which the liver is developing. So this ventral fold occupied by the liver, and so this stomach lesser curvature is connected to the liver by a fold, and the liver itself is connected to anterior abdominal wall by part of the ventral fold. So ventral fold is divided into two folds by the presence of the liver. On the back dorsal fold, there is developing spleen. So spleen has divided the dorsal fold into anterior part that connects the stomach greater curvature with the spleen, and posterior part, that spleen is connected to the posterior wall. You see, the stomach is much larger, greater curvature is much larger area than this spleen. So part of the dorsal mesentery above the development of the spleen connects the stomach directly to the diaphragm, and below that it hangs and becomes very large and connect it, the greater curvature, to the posterior abdominal wall. The detail of this will be discussed in the second part of this presentation. Now the cavity in this part has the right component. This embryo back is this one, so this is the right side of that embryo, and this one is the left cavity. So above the umbilicus, the baby has two component parts of the cavity. The peritoneal cavity is divided into left part and right part. Now this is the left part and this is the right part. So the rotation starts. The midline structure, the anterior part moves towards the right side, and the left cavity occupies the left side as well as the anterior part. Looks like this one. The part continues to rotate. So you see the left cavity is now coming in front, occupying most of the part of the front, and the right cavity is squeezed between liver and the stomach. It is mostly occupying the posterior part of the stomach. You can see this is the spleen, this is the stomach area, and this is the liver. So this is cavity is going back to this, only remaining behind the stomach, and this is moving anteriorly. If we continue, you can see this left cavity is now occupying most of the part of the anterior liver. This area will collapse almost, and now afterwards we'll get this cavity, a small cavity behind the stomach. Spleen will be like that. Fold will connect the spleen, then spleen will be connected to the posterior wall. Liver is connected, lesser curvature is connected to the liver, and liver with the anterior wall. And if you see a longitudinal section, median section, you can see this is the stomach area, developing stomach, and this one is the spleen. This is the liver, and you can see this liver, and this lesser curvature is connected to the liver. Liver is connected to the anterior wall. This is very early stage, and now this cavity is on the left side. The right is trapped. So left become the main cavity, and the left is continuous with the part of the cavity, the large cavity below the level of the umbilicus. This is the free margin of the anterior fold. Below that, actually, the left one continues. So this cavity is called sac, and this sac is the greater part of the sac. So this is known as greater sac, and the strap behind the stomach is known as lesser sac. So these folds and the sacs and spaces will be discussed in detail in the part 2 of this presentation. You can see relatively later stage of the development, stomach is there, and at this stage we will get peritoneum relatively well developed as a thin serous membrane. So we can define the peritoneum as a thin serous membrane comprising of mesothelium on thin layer of connective tissue that lines the wall of the abdomen as well as pelvic cavity, and the part who lines this is known as parietal layer, and the part who the peritoneum that tightly adherent to the wall of the viscera known as visceral layer of the peritoneum, and the organs are connected to the wall by the folds. These folds are usually called mesentery or meso. So here we can label like this. This is parietal peritoneum. We can see the peritoneum adherent to the wall is the visceral peritoneum, and you can see the folds that connects the organ to the wall is known as peritoneal folds. Then the cavity become trapped behind the stomach is relatively smaller, and it is known as lesser sac. You can see the color change, and the rest of the part is the greater sac. So greater sac below the umbilicus continuous with the main cavity. You can see this is the peritoneum, and this side peritoneum is removed, fat is also removed. So peritoneum, behind the peritoneum you can see the fat. So this is the peritoneum, parietal peritoneum covering the wall. It is the anterior wall looking from the back. So this is the ventral fold connecting the anterior wall with the liver. This is the peritoneal fold. This is the peritoneum, already I have shown, and peritoneum is removed from here and we can see the fascia. So this peritoneum, you can see here, behind this, between the peritoneum and the fascia, this is extraperitoneal tissue which is laden with fat. So this is known as extraperitoneal tissue. You can see the posterior abdominal wall. So peritoneum is there, behind extraperitoneal tissue and the fat is there, and you can see many organs lies in the extraperitoneal tissue. These are known as extraperitoneal organ or retroperitoneal organs. So these organs directly remaining on the posterior abdominal wall behind the thin peritoneal sheet and in the extraperitoneal tissue or fat are the retroperitoneal organs or extraperitoneal organs. You can see the posterior wall. So the transparent or translucent peritoneum is there. So through the peritoneum you can see all the organs. Okay, this is the kidney. You see this one is the kidney on the left side, and you can see part of the kidney on the right side. So both the kidneys are retroperitoneal. Above the peritoneal upper pole, these are the suprarenal glands. So they are also behind the peritoneum. All the organs I am showing are retroperitoneal. So this is the duodenum, and between the duodenum and the kidney, this is like the pancreas on the posterior wall. After duodenum, this is absent. This is in the inside the abdominal cavity. So these are not retroperitoneal. This is jejunum and ileum, cecum. So ascending colon is retroperitoneal. After that, transverse is within the cavity. So descending colon is again becoming the retroperitoneal in the abdomen. Sigmoid colon is not. So these are the retroperitoneal organ we can easily see through the peritoneum, and these all are fixed, relatively fixed, and cannot move because of the peritoneum tightly adheres them to the posterior wall. the great vessels. This is the aorta and this is the vena cava. These are also tightly adherent to the abdomen and retroperitoneal blood vessels. If you can see, this is after abdominal wall is removed, the yellow color peritoneum is visible attached to the greater curvature of the stomach. And if we get section in the median line, this is liver and this one is the diaphragm. This is looking like this one, and you can see the section of organs and cavities. So liver, spleen, these are intraperitoneal organs. Within the cavity they remain. Already in the previous slides I have shown the retroperitoneal. So liver, spleen, stomach, jejunum, ileum, cecum, transverse colon and sigmoid colon all are intraperitoneal organs lying within the cavity. All has visceral peritoneum covering the organs. This is the visceral peritoneum, and all are connected to the wall by folds. These are peritoneal folds. This is parietal peritoneum showing on the wall. So parietal peritoneum is firmly adherent to the diaphragm, and linea alba, you can remember in the midline anterior wall has linea alba. In both this area peritoneum is tightly adherent. Rest of the area, this is loosely separated by the extraperitoneal large amount of fat. Visceral peritoneum, you can see covering these walls of the organ. This is firmly adherent to the underlying viscera blending with the wall of the organ. It is often considered, usually considered as a layer of the wall of the organs. So the outermost layer is actually peritoneum, but histologically considered as component part of the wall of the organ, as it is very tightly adherent. And all the organs you can see in the inside the peritoneal cavity connected to the wall by the folds of peritoneum. These folds are having different names in different places. Mostly it is called mesentery and in short meso. Like for the small intestine it is the mesentery, for the sigmoid colon it is sigmoid mesocolon, and like that. This is considered some places like with the stomach it is called omentum, greater omentum, lesser omentum. Sometimes it is called as ligament, and uterus it is broad ligament. In the pelvic cavity there is sex variation, because the pelvic cavity contains uterus in case of female, but that is absent in case of male. So in male you can get, this is the pelvic cavity you can see, and this one is the rectum on the back, and peritoneum covers the anterolateral part, then lower mid part of the rectum, only anterior wall is covered, then it is reflected to the bladder upper surface. So this is covering the superior surface of the bladder. Is you can see this is the peritoneum covering the bladder, and it is reflected to the anterior abdominal wall directly. There is no folding between here, this rectum and bladder, there is a folding, and here it is not folded. In case of female, you can see this is the rectum that is covered anteriorly in the middle third, and superiorly it is also covering the lateral part, making a fold here, covers the uterus, then it making again fold to be covered the reflected over the bladder, and finally going to the anterior abdominal wall. In subsequent presentation I will go for the detail of the peritoneal reflection over the intestine in one part, and detail of the pelvic peritoneum in another part. Thank you very much for remaining with the presentation.